Hello there. In this video, we're going to complete the series of using techniques to solve a system of linear equations. This is the final one. This is going to be the elimination video, okay? In the previous two videos, we've done graphing, which can be the most unreliable because it's most prone to human error, and it relies on estimation, which could lead to faulty results. In the last video, we did substitution. In this video, we're going to use elimination. Now, I started with this example. Once again, we're using the same three examples from the previous two videos because we know their answers if you've watched them. If not, go back and watch them now. But we know the answers, so we know what we should come out to. And I'm going to start this example with the two that are in standard form because a standard form is the optimal situation to have a situation where you use elimination, okay? Now, in this, we need to look for two things. We need to find a variable, and you can pick one at random, it doesn't matter. We need to, typically, it'd be best to pick a variable where one's positive and one's minus. I know both of the x's are positive, but the y, one is negative and one is positive, so I'm going to eliminate the y. Now, the goal is to get those coefficients the same, which means I need this right here to be a 3. Now, I can't just plug a 3 in here. I got to think, what can I do to it? Well, previously, it is a 1. So I'm going to think multiplication. Well, what do I multiply 1 to get 3? I get multiplied to get 3. But, again, it's an equation. We have to keep it balanced, which means we got to multiply everything by 3. So bring this down here. 3 times 5 is 15x. 3 times negative 1 is the negative 3. And then 3 times negative 3 is negative 9. Okay, great. This is where we use the elimination, or in other words, we add these equations together and combine their like terms. So x plus 15x, well, that's 16x. 3 plus a negative 3, that cancels. That's supposed to be what happens. We want to eliminate one of the variables so that we can work through it with just one at a time. And then negative 23 minus 9 is negative 32. And we divide by 16, and we see we get x equals negative 2. Okay, awesome. Let's go ahead and plug that back into, I'll plug it into this one to solve for y. We get 5 times negative 2 minus y equals negative 3, and we're just solving a simple equation. So we get negative 10 minus y equals negative 3. Go ahead and add 10 to both sides, and we get negative y equals 7, but we want that to be a positive y, so we say y is equal to negative 7. So our final answer is negative 2, negative 7. And lo and behold, it's the exact same thing that we had in the previous two videos. Okay, awesome. Let's go ahead and go over another one. This is a good situation where you could use elimination because while we don't have standard form in both variables on either side, we do have a positive 1/5 x and a negative 1/5 x. So we actually kind of set ourselves up nicely. We don't have to multiply by anything. We can just add these right off the bat. I get y plus y. That's 2y. I get 1/5 x plus a negative 1/5 x. Those cancel. That's what's supposed to happen in elimination. Negative 4 plus negative 6, that's negative 10. And we divide by 2. This one turned out to be a nice, quick example. Let's go ahead and plug that back into this first one. So we get negative 5 equals 1/5 x minus 4. Let's go ahead and add 4 to both sides. So we get negative 1 equals 1/5 x, and then we'll multiply everything by 5. So this cancels, and we get negative 5 equals x, which means our final solution is negative 5, negative 5. So that, again, that problem was a little bit easier because we didn't need to multiply anything. We saw x had a positive and negative value, and their coefficients were opposite, so we could just combine them right off the bat. Let's go ahead and do this one. Of course, this was our problem where we had infinitely many solutions. So let's see what happens when we do that. I'm going to go ahead and I'm going to subtract 4x from both sides on this one. And I'm going to move it down here. I get negative 4x plus y equals 1. At this point, we got to look for a variable. None of them are opposites. So we got to multiply something by a negative. Now let's go ahead and go with y. But I noticed to get y to be 2, I have to multiply by 2. And to get them to be negatives, or opposites, I should say, I got to multiply by negative 2. But when I do that, so I'll rewrite it over here, negative 8x plus 2y equals 2, and then do this one right here. I get 8x minus 2y equals negative 2. And so when we add them together, everything cancels, and we get that same 0 equals 0 result we had in the substitution video, which means this is infinitely many solutions. And just recall that if you had gotten something like 0 equals 2, that is not a true statement. So that would be when you'd say there are no solutions. If you enjoyed this video, go ahead and give it a like and subscribe to the channel. If you want to see additional videos in the future, something specific, go ahead and leave a comment. And at this point, you've seen all three methods. Go ahead and leave a comment. What was your preferred method? Do you prefer elimination? Do you prefer substitution? Or do you prefer graphing? I do want to do a video in the future using graphing technology to do this. Let me know if you want to see that. And otherwise, I'll see you for the next video. Thanks for watching.